This week we will finish chapter 7 about the integer arithmetic. So in Tuesday, we will talk about extended addition and subtraction instruction, and we will go over multiplication and division instruction. On Thursday, we will continue with the ASCII display with the unpack and pack decimal arithmetic. So the first thing that's introduced, what are extended addition and subtraction instruction? So they are ADC instruction and SBB instruction. If you remember before when we talk about the add instruction, we sometimes say after you add, if your destination operand doesn't have enough value to hold, so that's why we will have the carry flag to be set. That means actually kind of your data is overflow. That means your data cannot be held within the limited storage. So continue, actually we can do is, since you only have 1 byte value to save until between 0 to 512, but how about I extend the value to the 2 bytes? Right, so that's the ADC instruction. So the ADC instruction actually is extended the precision addition. So that means if you have additional space you need to carry over the value, so then we need to use the ADC instruction. So we see how the ADC instruction will do. For example, we want to add 2 operands. They are longer than the computer double word size. So that means for 132-bit operand is not enough. But how about in the 32-bit environment, the most we can hold is 32-bit. So we need to try to see, can I have 2 32-bit operand to hold that? So that's we call the extended precision addition. So when your maximum operand value is 32-bit, so then if even 32-bit is not enough, so then we can add another 32-bit for the extended value. So this arithmetic will perform in the step. They will do 1 by 1. So the carry flag value actually will pass into the next operand instruction. So this ADC instruction actually is add the value with the carry flag. So they will add both the source operand and the content of the carry flag to the destination operand. So the ADC instruction operand syntax is the same as add or sub. So if you remember add and sub, you have in add and sub, we have add, then we have destination operand and the source operand. So right, the same thing for ADC. So add, we add the source operand to the destination operand. So we update the destination operand. So the same thing for ADC. ADC will do the same thing. But besides, we add source operand to the destination operand to update the destination operand. We also add the carry flag. Okay, so that's what we see here. So the same syntax, you have destination operand first, then source operand. So we will see how they will work as ADC. So for example, here we have 2 32-bit integer. They both are the maxima value. So here we just consider they are unsigned integer. So then when we add together, definitely 1 32-bit operand is not enough, right? So that's why we need to put the value not only in 1 32-bit operand. So we think about how about we want to extend our data. We want to using the EAX for the originally lower 32-bit. So then if they have more value, we save in the upper 32-bit is EDX. So when we do that, of course, the first thing we need to clear EDX. So then we have EAX equal to the value. So then we add the second value to EDX. So supposedly after we done, right, before our EDX value, so EAX value, before when we only have add instruction, the EAX value will be, right, still FF, 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 FE. So then because they add together. So after they add together, right, EAX equal to this value, right? But one thing is, actually, they did have the carry flag set. So before we just know, oh, we know the carry flag set, so that value is incorrect. But now, since we know the ADC, so on the other hand, we need to do is, we just need to have another 32-bit to have their extend value. So that's why here, continue with that, we can use the ADC instruction. So this ADC instruction is, we will just have our extend value to carry over. So since we don't have any value in the upper 32-bit, so then the EDX actually just add 0. But we don't use add, we use ADC. So ADC value will have the 0 add to the EDX and the carry flag value. If carry flag is set, we add 1. If carry flag is clear, so then we just add 0. So that's why here our result will have the correct value. So when we will use the ADC instruction, so actually, for example, if we really have very, very big value, so then they need to have multiple 32-bit operand. So then whenever we do that, we just have, because every time in 32-bit environment, we only can process 32-bit value, right? So then we just need to have the lowest 32-bit, we're using the add instruction. So then the next 32-bit or the higher 32-bit, more 32-bit, we're all using the ADC. Because this ADC will including the previous 32-bit operand addition, the carry flag. So that's the ADC instruction. So we can extend our value to the higher 32-bit. So the same thing, sometimes maybe we want to subtract, right? So then we will subtract also including the carry flag. So we call the SBB. So that's the subtract with the borrow. So this instruction will subtract both the source operand from the destination operand and including the carry flag. So then we see how they will work. So this one we just say, for example, I have a 32-bit value. So the higher 32-bit are using the EDX. So then the lower 32-bit we're using the EAX. So to help you to see here on the EAX, we're using the purple color. So when we have the bigger number, so we need to combine multiple 32-bit operand. So how about I want to subtract 2? What happened? So of course, the first thing we only can do 32 bits one time, right? So we use the EAX to subtract the 2. So 1 minus 2 become what? Become FFF, right? And also the carry flag will be borrowed. Right, so that's why you see here. When we have the value EDX equal to 7, EAX equal to 1. So now when we performed the sub instruction, so we only can focus on the EAX first. So this EAX I subtract by 2. But you know, 1 subtract by from 1 minus 2, they will become OFFF. And the carry flag will be set. So you see the EAX actually now become 1 2 1 2 1 2 1 2, become OF, right? And the carry flag is set. So that's why to including this carry flag is borrowed. So then when we subtract the EDX, so this EDX, because you only subtract by 2, right? So only EX will minus 2, but EDX will subtract 0. But this one, we don't use the sub. So in order to including the carry flag value from the previous 32-bit operation, so then here we're using the SBB. So this SBB will still using the EDX minus 0. So we add the EDX value. But addition to that, this EDX will also subtract the carry flag value. So 7 minus 1. So that's why our final value is here. So here, if you kind of still confused, or you can using this picture to help you to see. So earlier we have EDX and EX value. So we want to minus 2. So that's why we're only using this 32-bit operand to minus 2. But after we subtract, actually EX value will become OF, and the carry flag will be set. So in order to reflect from the EDX, the previous 32-bit, they did carry 1 to the lower 32-bit operand. So that's why the second one, instead using the SUB, we need to use the SBB. So that's why EDX, besides, they can minus the operand if they have. And also they will including the carry flag value to subtract. So that's the SBB. To help you to understand the SBB instruction, so then in our lab exercise 12, we will work on in multiple 32-bit operand. We see how we will work on that.